guys, today we'll be looking at drawing cubic graphs. In order for us to draw our function, we need to know the following. Stationary points and concavity. When a function is increasing, it has a positive gradient. This means that it slopes up to the right, therefore a function is increasing when the derivative is greater than 0. When a function is decreasing, it has a negative gradient, which means that it slopes down to the right. Therefore, a function is decreasing when the derivative is less than 0. And lastly, a graph has a stationary point when its gradient is 0. Therefore, at any stationary point, f of x is equal to 0. Drawing a cubic graph. To sketch a cubic function, you have to know the following. Number 1. Calculate the y-intercept, so you let x equal to 0. Number 2. Calculate the x-intercept, so you let y equal 0. Number 3. Calculate the coordinates of the stationary points, so you let the first derivative equal to 0. Number 4, calculate the coordinates of the point of inflection, so you let the second derivative equal to 0. Number 5, concavity, so we look at the second derivative in this situation. The concavity will tell us if the graph is increasing or decreasing at certain points. And then number 6, plot the points. In this example, it says, sketch the graph of f of x, which is equal to x cubed plus 6x squared plus 9x. Clearly show the intercepts on the axes, any stationary point or points, and the point of inflection. If we follow the steps that we've stated before, the first step says we need to work out the y-intercept. So, we have to let x equal to 0. We then substitute x is equal to 0 into our original function. So f of 0 is equal to 0 cubed plus 6 times 0 squared plus 9 times 0, and that gives me 0. So my y-intercept is therefore 0 and 0. Number 2, we need to calculate the x-intercepts. In order for us to do this, we need to let y equal to 0. We have to substitute that 0 into our original function. So we have 0 is equal to x cubed plus 6x squared plus 9x. Now we are trying to find out x values, right, for our x-intercept. So in order for us to do that, we need to go ahead and factorize. Now the factorization that we can use in this situation is take out the highest common factor, which in this case is x. So we are then left with 0 is equal to x times x squared plus 6x plus 9. Now inside my bracket, you can see that that is a trinomial. And what we know about trinomials is that they can be factorized even further. So we have 0 is equal to x times x plus 3 times x plus 3. X is therefore equal to 0, or x is equal to minus 3. My x-intercepts are then 0 and 0 and minus 3 and 0. Number 3. We have to work out the stationary points. In order for us to do this, we need to let the first derivative equal to 0. And how do we do that? We first need to find the first derivative. So, we need to derive our original function. When we do this, we should be left with 3x squared plus 12x plus 9. Here we can simplify even further by dividing by 3, and we should be left with 0 is equal to x squared plus 4x plus 3. Now again, this is a trinomial, which means it can be factorized even further. So 0 is equal to x plus 1 times x plus 3. Therefore, x is equal to minus 1, or x is equal to minus 3. At this point, we have x values that we can then substitute back into our original function so that we can get the y values of that function. So, we are subbing in the x values into f of x, and f of minus 1 is equal to minus 1 cubed plus 6 times minus 1 squared plus 9 times minus 1, which is equal to minus 4, and f of minus 3 is equal to minus 3 cubed plus 6 times minus 3 squared plus 9 times minus 3, which is equal to 0. Therefore, our stationary points are minus 3 and 0, and minus 1 and minus 4. Number 4, concavity. We look at the sign of the second derivative. So we have to derive the first derivative in order for us to get the second derivative. And that equation is therefore equal to 6x plus 12. When x is equal to minus 3, the derivative of minus 3 is equal to 6 times minus 3 plus 12, and the derivative of minus 3 is equal to minus 6. Now, remember concavity, you are basically proving where the graph is going up. So it's concave up or concave down. Now, when the graph is less than 0, that means that it is concave down at minus 3 and 0. And that tells me that it's a local maximum at minus 3 and 0. Okay? When x is equal to minus 1, we substitute it into our second derivative as well. So the second derivative of minus 1 is equal to 6 times minus 1 plus 12, and we get a value of 6. Now 6 is greater than 0, which means that the curve is concave up at minus 1 and minus 4, and that also tells me that it's a local minimum at minus 1 and minus 4. Number 5, the point of inflection. In order for us to calculate the point of inflection, we need to let the second derivative equal to 0, then substitute in an x value into the original function. So, we let the second derivative equal to 0, so we have 0 is equal to 6x plus 12. 6x is equal to minus 12, and now we're just solving for x, so x is equal to minus 2. Now that we have an x value, we have to substitute that back into our original function. So we should have the f of minus 2 is equal to minus 2 cubed plus 6 times minus 2 squared plus 9 times minus 2, and that should give me minus 8 plus 24 minus 18, and therefore the answer should be minus 2. So my point of inflection is at minus 2 and minus 2. Now that we've calculated everything we need to know in order for us to construct our graph, we can then go ahead and actually plot our points and draw the graph. So, if you look at the function in front of you, I have the coordinates of my local maximum, which is minus 3 and 0, as well as my point of inflection, which is minus 2 and minus 2. At the bottom, I have minus 1 and minus 4, and that is my local minimum. And then I also have my y-intercept, which we know is the origin, which is 0 and 0. And then, as always, whenever you are drawing a graph, you always have to label the function. So I have f of x. Now it's your turn. Please complete exercise 9.10 on page 209 in your Clever textbook. Enjoy!